Good afternoon, class. I just wanted to take this opportunity to create a video and show you how to do the data analyses for homework 2 in SPSS. Um, so here I have the data set open. This is the in-class data and also the in-class data document. So these are all the questions and analyses that we will be going through today. So just to start off with, we want to figure out what the percentage of women are in the sample and also what the mean age is for the sample. So to do that, we're going to go to Analyze, Descriptives, Frequencies, and we're doing gender and age. And make sure we get the mean. Hit Continue. Then we're going to paste it. Got the syntax and hit Run. Alright, so here we have our gender frequency table, and this tells us what the percentages are for each gender. So for women, female, we are at 50%. And that is correct. Alright, now age. I'm going to scroll down. Oh, there it is. So the mean age was 23.67, or excuse me, 23.66. Rounds that to 23.67. And that should be 23.67. So there we go for the first question. The second question is, what is the kurtosis and skewness of the average of the test mean? And is the average of the test grade significantly different than the population average? And the population average being 8.00. At this point, I should note that there are a couple types of t-tests. And this in-class practice data and also the homework covers all three types. So the first type is the one sample t-test. And so essentially what the one sample t-test is looking at mean differences in your single sample and comparing it to a population average or a population mean. Kind of the dead giveaway for the one sample t-test is the inclusion of a population average. So in the homework, if you see a question that has the population average included, you know right from the start that you will be conducting a one sample t-test. So let's go ahead and look at test mean and calculate the skewness and kurtosis. Now in the homework, I believe you have a similar question, except I do not include the variable test mean. For that, you'll have to actually compute the new variable. And just to recall, to do that, you go to transform, compute, and then run through. Make your target variable name, so that's the name of the new variable, and enter in your equation. So for this, that would be mean parentheses time 1 and time 2. But anyway, so to get that skewness and kurtosis, analyze descriptives and frequencies. We're going to toss over our test mean, go to statistics, and check the box for skewness and kurtosis. And hit continue. And I'm just going to hit paste. Go to syntax, highlight, and run it. Alright, so here we see our variable test mean. The skewness was negative 0.220, and the kurtosis was negative 916. So this is slightly negatively skewed, and this is, I believe, platykurtic. So again, skewness refers to kind of the horizontal shift of the distribution of your data, whereas kurtosis is kind of the vertical shift of your data, or vertical distribution. So let's go ahead and check that. And then we would say that the test mean values were slightly negatively skewed at negative 0.220 and slightly platykurtic, negative 916. From there, we're going to go ahead and do the one sample t-test. So we're going to go back to our data. All right, so to do the t-test, we go to Analyze. And since we're comparing means, we definitely want to click on Compare Means. You see here, there are a range of options, and we are doing one sample t-test. So we're going to click that. We're doing it for the test mean variable. Click that over, and you see here, there's a box that says test value. This is where you would enter your population average. Ours is 8. We're going to click that. There are really no options to click. Just leave that as default. And then we're going to paste it, highlight it, and run. Alright, so this chart just tells us our mean for the test mean for our sample. So our sample mean is 7.05. So off the bat, we know that that is actually slightly lower than our population average. But is that a significant difference? So here we're going to look at our one sample t-test box. You can check this box, the test value, just to make sure you actually had it entered. If you forget to enter the test value, then the entire analysis is off. So make sure, please make sure that you enter in that population average. Alright, so with a t-test, we get our t. So the t coefficient, or the t is the coefficient for our one sample t-test. And that value is negative 2.415. And if we're rounding, it would be negative 2.42. Our degrees of freedom are 29. And degrees of freedom is calculated as n minus 1. So n being your sample size. So 30 minus 1 is 29. So that's correct. And then sig is our significance. So our p-value. And our p-value is 0.022. And as you recall, any p-value that is less than 0.05 is in fact statistically significant. So congratulations! We do have a significant difference between our population average and our sample mean. In this case, our sample mean is significantly less than our population average. So to report that, we're going to write it out like this. So first off, you want to state the data analysis that you conducted. So we're going to say a one sample t-test revealed that the average test grades, quote the mean equals 7.05, of our sample was significantly lower than the population average of 8. And so this is being reported in APA style. And so there's a certain way that we want to do that. So first we're going to say t, again that t-test coefficient. In parentheses, we have our degrees of freedom, which was 29, equals negative 2.415, which was our t-value. And then we're saying p is less than 0.05, because it was in fact statistically significant. All right, moving on to number 3. Is there a difference between test 1 and test 2? So to find that out, we have to do another t-test. But this one is going to be a different type of t-test from the one that we did in question 2. It's not a one sample t-test. It is in fact a paired sample t-test. And the difference here, and the reason why it's paired sample, is because we essentially did a pre-test, post-test, where we have the same group of people that we gave our test to and calculated their grade. So that would be test 1. And then we did whatever our experiment was, whatever our treatment was, and then we assessed them again and got another set of scores, and that is test 2. And just to kind of help you understand the differences between the t-test, I did include a document called Types of T-Test in the SPSS2 folder in Module 3 on Blackboard. And if you open that up, you'll get this document. And it just runs through the basic description and basic differences between the 3 types. So here we're doing paired sample. Alright, so let's go ahead and run that. So we're going to go back to Analyze, Compare Means, and we're doing paired sample t-test. So we click that, and you see here, so variable 1 and variable 2. Variable 1 and 2 would be test 2. Simple as that, folks. Paste, get our syntax, highlight, and run. Alright, and so the first box just shows our descriptives. So we have our mean for test 1 was 6.5, 30 people. Our mean for test 2 was 7.6. So off the bat, you see that there is a difference numerically. But we don't know if that difference is statistically significant. So to figure that out, we're going to go to our paired sample t-test box or table and look. So, just the difference between the two is 1.1. And our t was negative 4.097. Degrees of freedom is 30. Our significance was 0.000. So that is less than 0.05 and therefore statistically significant. And I should also note here that if you have a t and it is greater than 2, it's likely to be statistically significant. Now, that's not always the case, but that's just kind of a general rule of thumb. If your t-value is greater than 2, then it is likely to be significant. And that depends on your degrees of freedom as well, but we are good. So now that we've run that data analysis, we need to report it. And we do so in a similar fashion to the first, or rather second question, and quote the data analysis that we ran. That would be the paired sample t-test. So we're going to say that a paired sample t-test was conducted to assess mean differences in scores between test 1 and test 2. Data analysis indicated that test 1 scores, quote the mean, m equals 6.5, were significantly lower than test 2 scores, the mean equals 7.6. And then we're going to report the t-value in APA style. So t, the degrees of freedom, is 29, equaled negative 4.097, and our p was less than 0.05. You can put 0.05, or in this case, ours was actually less than 0.001, so we can say that. And then we kind of want to clarify the differences and say that is to say that participants scored higher on test 2 than on test 1. There you go. We have successfully completed a 1 sample t-test and a paired sample t-test. Alright, from there we're going to go ahead and do our last t-test. And this one is going to be the independent samples t-test. The question is, are there gender differences in the average of the 2 test scores? 1 meaning male and 2 being female. And so since we're looking at 2 independent groups, so 2 different groups of people, we know that we have to do an independent samples t-test because participants can't be male or female. They're either in group 1 or group 2. So we're going to head back to SPSS. and it wanted to look at the average of the test scores. So we're using the variable test mean as our dependent variable, and gender is our independent variable. So we go to analyze, compare means, and independent samples. So here we see something that we haven't seen before. That's test variables and grouping variables. So the test variable is your dependent variable. In this case, it's test mean. The grouping variable will be your independent variable, which we are using gender. But you have to define the groups. And so that's why knowing that, 1 and 2. So group 1, make it 1 for male, 2 for female, and continue. Then we're going to hit paste, find our syntax, highlight it, and run. So here we can see that males had a mean of 6.066 and females had a mean of 8.03. So again, we see that females scored higher than men, but we don't know if that difference is statistically significant. All right, figure that out. We're going to look at our independent samples t-test box. So the first thing you see here is the Levene's test of equality of variance. Now this is not the t-test. What test of equality does is it just makes sure that your variances are equal before you run the data analysis. Because one of the assumptions of a t-test is that you have equal variances. And so F was 0.974, significance was 0.332, which means that there were no differences in the variance between our two groups, which is almost the one time in statistics when you do not want a significant difference. So that's great. So we move on over. There's our t. Our t value was negative 2.772. Our degrees of freedom is 28. I should note that had this been significant, instead of using this t in degrees of freedom, we would use this t in degrees of freedom. And that's because SPSS does this wizardry and balances out the variances so that we can conduct the t-test. But we don't need that. So our t, degrees of freedom, our significance is 0.01. So that is less than 0.05 and therefore statistically significant. So we're going to go ahead and report that and say that an independent samples t-test was conducted to assess gender differences in test scores. And the data analysis indicated that on average, men with a mean of 6.07 scored significantly lower than women, a mean of 8.03. Got our t. Quote our degrees of freedom, which was 28, equals negative 0.2772, and our p was less than 0.05. In this case, it was right on 0.01. So I believe you can say it's less than 0.01, but just to be on the safe side, we'll say it's less than 0.05. But either way, it is statistically significant. All right, now we come to our last question. Are test 1 and age significantly correlated? And also conduct a partial correlation between test 2 and age controlling for gender. And is there a significant relationship there? From the PowerPoint and your book readings of Chapter 2, you learned what and why you would conduct a correlation, and also what a partial correlation is and why you would conduct a partial correlation. And the reason why you would conduct a partial correlation is to still look at the correlation between two variables, but you might do it because you want to control for another variable. In this case, we want to look at test 2 and age, but we want to control for the effect of gender. So let's go ahead and do the first correlation between test 1 and age. So we go back to SPSS, go to Analyze, Correlate, and pick Bivariate. So we got test 1, age. The default setting is a Pearson, and that's what we want to use. 2 tells default, so we would also click that. Options, nothing there unless you just want the means and standard deviations. In this case, we're not going to bother with that. Got everything set, and paste. Go to syntax, highlight, and run. So here we have our correlation box, and so we're looking at test 1 and age. So the Pearson correlation is the correlation. It's our correlation coefficient, which is our little r, and that value was negative 0.378. And if you recall from chapter 5, the correlation ranges from -1 to +1. The closer to 1 that value is, the stronger the correlation. And ours here is negative 3.78. Look at our significance, and it is 0.039, which is less than 0.05, and therefore a significant correlation. So we're going to report that and say that test 1 scores and age were significantly correlated. Our little r, in parentheses we put 3, but I believe that should be 30. Yes, it should be 30. So that would be our n. So our n, 30, equals negative 3.78. And p was in fact less than 0.05. Alright, now we want to run that partial correlation. So we're going to say, go back to SPSS. We're going to go back to Analyze, Correlate, and instead of doing bivariate, we want to do that partial correlation, so we select partial. Alright, so the 2 variables we're looking at are test 2 and age, so they go in the variables box, but we're also controlling for gender, so make sure you put gender in the controlling for box. I'm going to paste, go to syntax, highlight it, and run. Alright, and so this correlation table looks very similar to the first one we ran, except we indicate that we did in fact control for gender. So we're going to look at age and test 2, or we're going to look at test 2 and age, either way. Our correlation was negative 0.251. Our p-value, or significance level, turned out to be 0.189. So that's larger than 0.05 and therefore is not significant. So we want to go ahead and report that and say a partial correlation between test 1 and test 2, or excuse me, between test 2 and age controlling for gender revealed no significant relationship. So R, and instead of 30, for the partial correlation, we use our degrees of freedom, which in this case was 27, and that R equaled negative 0.251, and our P was not significant, so we can say that our P equaled 0.18, which it did. Alternatively, you can simply say P equaled NS. NS meaning our P value was not significant. So P equaled NS. And there we go. We are done with all of our data analysis. So we want to make sure that we attach our syntax. And to do that, just highlight everything and copy and paste it. And paste it in the document. And there we go. If you have any questions or comments about this assignment and about the course, please email me and I'll get back to you as soon as possible. Take care.